Hello, grade 11. Welcome to your virtual school lesson, which is exponential function or exponential model. So today you're going to learn, or at least your learning goal is to make sure that you understand and you know what is an exponential model. And also in this lesson, you need to be able to sketch an exponential model. So an exponential model has a physical feature that looks like this in general. So in the previous lessons, we already discussed and you learned linear model, which is a straight line, and then quadratic model, which is a parabola, and an exponential function or model will look like this. Okay, so this exponential function is basically different from what you have learned before. And here's one example of what is an exponential function. F of x is equal to 2 raised to x. Okay, 2 is base and your independent variable is the exponent. So this is the difference between what you have learned before. You used to have your independent variable down here as the base and included in your equation. So this time your variable is an exponent. So let's look at the graph of the function by plotting some points using the table of function. So remember that whenever we use in class, when we are plotting a graph and using function table, we assigned ourselves the values of x. So let's do that. Let's assign 3 to x. So if we use this equation, 2 raised to the third power, it's going to be 8. So your x coordinate is 3 and your y coordinate is 8. If you plot that, there's your 3 and then your 8 in y-axis. Okay, let's give another value for your x, which is 2. So then if 2 is raised to the second power, then your y is equal to 4. So let's graph the coordinates 2 and 4. If you go over here, that will be over here. So 2 and then 4. Let's give one more. 2 raised to the first power is 2. So your coordinates are 1 and 2. Let's graph that. There you go. And then another value is 0. 2 raised to the 0 power. As you know, any number or any variable raised to the 0 power, it is equal to 1. So you have your point over here. When x is 0, your y is 1. Now, if we give the value -1 to your exponent, let's remember that negative exponent does not mean a negative y or a negative value. It only means that you have a value less than 1 or a fraction. So 2 raised to -1 is 1 over 2, which is 0.5. So your point is over here. And then if you have a -2, that's your y is 1/4. And if we plot that, your point is over here. And then the last one being -3, that's the same as 1 over 8. Okay, that means 2 raised to the -3. It means 1 over 2 raised to the third power, which is 1/8. Okay, so if we connect the points, we're going to have a graph that looks like this. Okay, so this is what your exponential model will look like. Now, let's continue. One of the things that is important to know is the word asymptote. Asymptote appears in an exponential model. It's a line that a curve approaches as it heads towards infinity. At this moment, what's important is that you know what is the horizontal asymptote. There are two asymptotes, a vertical and horizontal asymptote, and there's another one which is oblique, and we're not going to study that. Okay, so the important asymptote is the horizontal asymptote. Okay, so you will always have this b. This b is your value at y, that when you make a horizontal line, that's only like the boundary of your curve or the boundary of your exponential model. Your curve is not going to go beyond that b. So for the horizontal asymptote, as your x approaches infinity or negative infinity, then the curve approaches some constant value of b. Just like what I have mentioned, it will not go beyond b. And so let's look at some graphs of exponential function, or let's look at some exponential models. We already did the model for 2 raised to the x, so here it is again, once again, here. Okay, let's take a look at the model if it's 2 raised to x plus 3. Okay, so with a constant 3, that means that your graph is going to go up 3 units. So that would look like this, from 2 raised to x, because you added a constant that raised your graph to 3 units up. Now remember that if you want to take a look at this equation, there's actually a plus a 0 here. Okay, so when it's plus 0, you are done here. And you will see why it's here later on. Okay. Now another important thing to know is that what if you have a negative value? Okay, you have a constant here, okay, which is 1, that will be your c. Okay, and but in here you have a negative 2 raised to the x. So let's take a look what happens. It will reflect over x-axis. So this is your positive 2 raised to the x. A negative 2 raised to the x will look like this. Okay, so it has reflected over. Okay, so let's take a look at the format to make it easier for you. In general, your f of x, when it's an exponential function, is you have k times a raised to the x plus c. Your a, the element, is rational positive rational number, and your k will never be 0, and your a cannot be equal to 1. Okay, so the format is this. To know right away what is the horizontal asymptote, c is your horizontal asymptote. Like c is your y-intercept in quadratic equation, and then the same thing in linear function. Now, in exponential model, the curve passes through the point. This is your y-intercept, so don't be misled. C in exponential function is your horizontal asymptote. On the other hand, the y-intercept, your y-intercept in linear and then quadratic functions, is 0k plus c. So the value here in front of your a and then plus c. So let's have an example. Find the coordinates of a point where the curve cuts the y-axis. The one that cuts the y-axis is your y-intercept. And then on B, let's write the equation of the horizontal asymptote. Okay, for the first one, the point that cuts the y-axis, we are following this. It says 0, so I wrote 0 for your x. And then k, what is your k? The k is the number besides 6, because you don't see a number there. That means it's 1. And then on this equation as well, we don't see the c. That means it's plus 0. So I wrote 0. And to simplify, your y-intercept is 0, 1. Now, for the horizontal asymptote, it says y is equal to c. In this equation, you don't see a plus c or a minus c. So it means that your c is equal to 0. So your horizontal asymptote is y is equal to 0. Let's have another example. What if it's 1/5 raised to the x? Okay, again, y-intercept, you're going to follow this format. You right away write 0, and then your k, that should be the number beside 1/5, and you don't see anything here. That means it's 1, and there's no plus a number or minus a number. That means that your c is 0, so it's 1 plus 0. So your y-intercept is 0, 1. And then your horizontal asymptote, y is equal to c, and you do not see any constant after this, so that means y is equal to 0. Okay, let's move on to another example. Here we go. You see more numbers now. Coordinates of the point where the curve cuts the y-axis. We're looking for the y-intercept, so we're looking for this 0, comma, k plus c, so we have 0. Our k is the number beside 2, or the coefficient, so that's 3. And then your c is plus 4, so you have 3 plus 4. So your y-intercept is 0, 7. That's your point. How about your horizontal asymptote? Your horizontal asymptote then is your c. In this equation, your c is 4. So you just simply write y is equal to 4. Okay, I hope that that was easy for you to follow. Okay, now another example. We know it's 0 for the y-intercept, x is 0, and your y is -4 minus 2. So then your y-intercept is 0, -6. How about the your horizontal asymptote? It's simply your c, and your c is -2. That means your y is -2. Okay, now be ready for checking the understanding. Answer these 4 problems, write them in your notebook or in a Google document, and share them with me. Okay, this is the first part of the question. So after this, you still have to watch, and you still have to keep watching. Pause the video and answer these 4 questions. Write the y-intercept and the horizontal asymptote, just like what we did in the examples. Okay, that's done. Now, let's try sketching a graph of the function. Use what you know already. You need to write what is the y-intercept and the horizontal asymptote. Given f of x 3 times 2 raised to the x minus 1, your y-intercept is going to be 0, 3 minus 1. So then your y-intercept is 0, 2, and that will be your y-intercept. And then what will be your horizontal asymptote? Your horizontal asymptote is your c, which is -1. So your horizontal asymptote is y is -1. So when you graph it, here you go. You just draw a line in a -1, and when you draw this figure, you are going down this way. It will touch 0, 2, and you go and do a curve that will not pass through -1. Okay, now that you have seen this example, I want you to make 2 graphs for these 2 functions and solve this word problem in your notebook. If you use your notebook, make sure that you take a picture and email it to me after the session is over. If you use a Google Doc, you can use a graphing, a table or a chart to graph your functions. Also, make sure that you use your calculator so you know what it looks like. Use the y equals to see what your graph looks like. Good luck, grade 11, and I hope you send your solutions to me after your class, before your class is over. Bye.